it. And yeah, so we'll give it about another minute or so for any other people that want to come in to get to the Zoom meeting, and then we'll go ahead and get started with more cross tabulation exercises. Okay, well, let me see if I can get to my screen to take a look at the assignment that's the next assignment that's due that has you doing cross tabulation exercises. Where is it at? Let me go back to here. Okay. Yeah, so this one is the one that's due come up here on the 22nd. And can people see my screen? I just changed it. Can you see that? It's just assignment 5 due to, okay, great. So this is the assignment that you are to complete, and what we can do today is we can go through and I can tell you what the answers should be, and then at the end of this assignment, you see at the bottom it says create a new crosstabs table using 2 variables, your choice. Make sure variables have no more than 5 levels of measurement to them. And I mentioned before the problem. I'll show you an example. If you put like a 10 by 10 table in there, it's going to have 100 cells in it. It gets it may not work for cross tabulation purposes. And then you're to save your SPS output so that I can see your table. You can cut and paste that into a Word document, or you can just upload the output. It's fine. I just need to see the table that you make using the crosstabs analysis and do the interpretation, or that is just, produce your table. I'm not asking you to do any interpretation on it, no. But for these assignments, for this assignment that's due on the 22nd, I'm asking you to produce a table and answer these questions about them. So let's go ahead and do that. Okay, so I'm asking you to create a crosstabs table in SPSS that uses the race variable for the rows and that uses the easy access to gun in the home variable for the columns. Now in crosstabs, it does not matter if you put race in the columns and easy access to gun in the rows. If you did it reversed, it doesn't matter. It's going to give you, the table contains the same information. It'll just be transposed. It'll just be flipped around as to what's in the columns and what's in the rows. Okay, so let me go to SPSS. And first, let's take a look at these variables so we know what how it's measuring these things. So this variable right here is this H1 GI9, I believe so. That's the race variable that I want you to use for this. And this is the label for it. Okay, and so this is how it was measured. So 1's white, 2 is black, 3 is Asian, American Indian, 4 is Asian, 5 is other. Okay, and so they have other questions in here that ask about race, ethnicity. They get some more detail than this. But anyway, this is the one that we're using, that there's not too many people that are missing on this variable. So that's another good reason to use it. So that's what we're going to put for the rows. And then for the variable that asks about access to a gun in the house, that's H1TO53. And I'm going to, whenever you're doing this, you can go highlight that, then Control F, and then you can just type in your variable to get to it. H1TO53, enter. Well, why not? Did I not? What did I type it wrong? H1TO53. Okay, I must put a 0 instead of an O. All right, so this is this variable, easy access to a gun in the home. Now, you always can look at the entire question if you look at the AdHealth survey that's posted on Moodle, but this is what was asked of the respondents. And so it was just a binary dummy coded thing. No, they didn't have easy access to a gun in the home, or yes, they did, and the rest are missing categories. The 6, 8, and the 9 are missing categories. Okay, so that's how these two variables are measured. And whenever you're doing any analyses, it's always good to look at how your variables are measured first before you get into anything else, because that will make the interpretation more predictable. You kind of know what you're going to get, or at least you have some grounding in how things should turn out. All right, so when we do the cross tabulation table, we have to go to Analyze, and we go to Descriptive Stats, and then we go to where it says Cross Tabs Table. So I had done this earlier today, so I just showing here that I put in the rows, I put the variable for race, and that's the H1GI9, and then I put in the columns, this is the variable for easy access to gun and home. That's H1TO53, so I put those over there. And to get your chi-square stat, remember you have to click on statistics and click where it says chi-square, and then you also need to click on where it says cells, and you'll need to click on row, column, and total to make sure those are clicked on. So you'll get those in the output, and hit continue. And then go ahead and hit OK. And let me go back to that screen because I think it probably clicked off. Okay, right. And so here you should be able to see my output table. Somebody just wave at the screen and tell me, no, I can't see it if you can't see this, but this should show you the output from that cross tabulation table. And so you should see up top here, it should race of interviewer by easy access to gun in the home. And so there are a total of 65 people that did not answer both those questions. And so there's 6,439 people who gave valid responses to that question, to both those questions. All right, and so what we look at here is our crosstabs table here with race in the rows and gun ownership, no, yes, in the columns. And so the first question that I ask, let me go back to that so we can look at that. Okay, so the first question I ask, which race is most likely to say they have easy access to a gun in the home? Okay, so just you want to pay attention to how this thing is worded, because when you word it differently, I'm asking a different question. But this one is asking which race is most likely to say they have easy access to a gun in the home. All right. So when we do that, when we ask that question, so we say, okay, within which racial category is there the highest percentage of people saying, yes, they have easy access to the gun in the home? So maybe that word likely is not the best used word to use in that sentence, but I meant also which racial category is most likely or has the highest percentage of people saying yes, they have easy access to a gun in the home. And so what we have to do, we're looking at this row wise now. So we say, okay, among whites, what percent has easy access to a gun in the home? 29.6% among whites. Among blacks or African Americans, it's 15.3% say that they have easy access to a gun in the home. Among American Indians or Native Americans, 6.9% say that they have easy access to a gun in the home. Among Asians and Pacific Islanders is 11.9%. Among others, it's 10.6%. So notice I'm reading this row wise. So when you read a row wise, you look at this first set of percentages going across top of the cell. And so, okay, so which racial group is most likely to say that they have easy access to gun in the home? Well, according to this, it is whites. So you have among whites, another way to say it, 29.6% say they have easy access to a gun in the home. That's the highest compared to any other racial group because blacks are 15.5, American Indian 6.9, Asians at 11.9%, others at 10.6%. Okay. And so we go back to this question. Again, that was the question that asked which race is most likely to say they have easy access to a gun in the home. Okay, so that would be whites with 29.6% saying they have easy access to a gun in the home compared to everybody else. So within all those other racial groups, it was lower proportion of said group said that they had easy access to a gun in the home. Okay, so this is which race is least likely to say they have easy access to gun in the home. So I'm just asking the opposite, which is the least likely, which a racial group is least likely to say they have gun in the home, or which has the lowest percentage of yes. There's another way that I could have said that. And so when we look at the output, okay, and so definitely not whites, African Americans at 15.5%, American Indian only at 6.9%, Asian Pacific that's at 11.9%, and others at 10.6%. So yeah, it's American Indians are the group that's saying that they have least likely to have easy access to a gun in the home, with only 6.9% of them saying it. Okay, so that's an example of reading this table row-wise. So you're reading it by looking at, okay, within each one of these racial groupings, which subsamples has said yes to this question or no to this question. All right, so stop me at any point you have questions about how, why is it that? Just remember, look at this where it says within race here. Each one of these cells, it says that. So you're reading it row-wise because race is over here on the row side, whereas we'll get to this in a moment. The second percentages down here are reading this column-wise. So among people who said yes to this question, what percent are white, etc. All right, so let me go back to this. And again, if there's any questions, just shout out or start waving your hand furiously at the screen. Next question, how many Asians are there in the sample? Just period, question mark. How many Asians are there in the sample? Okay, so that's looking at a total count of Asians in the sample. And so going back here, so right here, Asians, Pacific Islanders. So this is the breakdown of how many Asians said they don't have easy access to the guns and how many that did. But there's a total of 236 Asians or Pacific Islanders in the sample. Total. Okay, so 236, that's the total number of Asians in the sample. Next question. how many blacks are there in the sample? Okay, so this is the same here. It's the same question, basically, just switching categories on you. And so total number of blacks or African Americans in the sample. Again, this is the breakdown by the number who said no to the easy access question, the number who said yes, but total number of blacks or African Americans in the sample, 1,582. Okay. All right, next question is, what percent of the sample is other race? Okay, so what percent of the sample overall is other race? Okay, so we can find that out by looking back at this output. And so go down, here's other, the totals. And so it's out of the total sample, it's 4.5% is other race. So 4.5% of the sample is other race. So we're looking at the margins of the totals right there now. And the next one, oops, wrong screen. What percent of those who have easy access to guns are white? Okay, so what percent of those who have easy access to guns are white? So out of all the people who said they have easy access to guns, what percent are white? Okay, so for that, it would be, so of those people who have easy access to guns, what percent are white? That would be 80.5%. Because it's saying of those people who all share that they have easy access to guns in common, what percent of those people, of those 1,567 people are white? What percentage of them are white? Well, that's 80.5% of them are white, or 1,261. Percent of the sample, though, is out of this, that is out of the people who said that they have easy access to the gun. That's 80.5% of them are white. All right, and so for what percent of those who have easy access to guns are black? Okay, so that's the same kind of question where you're looking at this column-wise now. What percent of the sample has easy access to guns are black? And that would be 15.4%. Okay. So those are examples of how you read a table row-wise, how you read it column-wise, when you're looking at in the margins, looking at the totals in the table. So with crosstabs, yeah, you can look at, you can get a lot of information from a crosstabs table. The one other thing I want to point out with this crosstabs table is down here, here's your chi-square test. And so the chi-square test, the actual chi-square value came out to be 196.379. And so we want to know, is that a statistically significant chi-square? And if so, what would that mean? Well, if it's a statistically significant chi-square statistic, that means that there are significant differences in proportions across racial groups as to who says they have easy access to a gun in the home. And we kind of can figure out who it is at this point that has easier access to a gun, disproportionately easy access to guns. They say, well, that's whites at 29.6%. Compared to the low of Native American Indians with only 6.9%. And so there's clear gaps here if you look at it within racial category, who has easy access to gun, who does not. So the question is, the chi-square question is, well, overall, are there bigger differences? Are there big differences across any of these categories, bigger than what we'd expect by chance, or bigger than what we'd expect if all the cells were, the counts in them were divided up evenly, so to speak, in proportion to the numbers going in. And so that's what it's, remember back to the chi-square equation, that's what's called observed counts versus expected counts. And so with this, we don't have to use the table per se. We can just look to see the chi-square value is this 196. And this says it has 4 degrees of freedom, which the degrees of freedom is calculated by the columns, number of columns minus 1 times the number of rows minus 1. So here it'd be 4 times 1, and so that's why the degrees of freedom is 4. And so that's where you look to see what column you look up at in the table, in the chi-square table. But what's showing you over here, that is the probability that these differences in observed and expected frequencies are there merely by chance. And that is saying that it's about 0. It's pretty much 0 that these differences were found merely by chance, because the differences between what's expected and what is observed is so big. And we can see where the big differences are, as I just highlighted with the differences across racial categories, that there is a statistically significant difference with regard to which group is saying that they have easy access to a gun. And so this is a chi-square test that tests for a significant difference in proportions or percentages. And so you will want to produce one of these tables. And these tables should not have too many levels to the variables that you pick out. So you're picking out 2 variables. And don't use the exact examples that we used in class. Please pick out something else. But they shouldn't have lots of levels to them, like a variable that ranges from 0 to 100 is not good for chi-square, because chi-square requires that there's not a lot of cell counts that are 0 to actually calculate the chi-square. And so you'll see this little note down here that says 0 cells, 0% have an expected count less than 5. The minimum expected count is 17.52. And so that is one of the reasons why you just don't want to have in your own table a chi-square table that has variables that have more than like 4 or 5 levels to them, because the number of cells that have 0 in it will make the chi-square value maybe uncalculable, or it's not valid. The other thing, it's very hard to read it. It's very hard to look at it if you have a chi-square table that has just lots and lots of levels to it on both sides. That is a variable that has more than 4 or 5 levels to it. Chi-square is usually best if you have variables, nominal variables like this, or variables that have a very small number of levels to them. That there's it's numbered 1 through 5, or the outcomes are 0, 1. So that's what you are aiming for in your homework assignment, is to produce a chi-square table that's readable, that does not have too many levels to it. Okay. So are there questions about chi-square tables so far, about what we've gone over here with how you read a chi-square table, row-wise, column-wise, what the chi-square test actually is showing you? Anything like that? Okay. So, Friday is when your exam is due. That's due on the 19th. Right. Yeah, I'm doing the 19th on, so that's Friday night. So if there are questions about that, you can come to the homework session on Friday. That'll still be in effect. And then we will There is stuff on t-tests that we're going to move on to next. That's the next thing we're going to cover. We'll start that on Monday. T-tests deal with testing for differences in averages. So this is testing for a difference in proportions. T-tests are tests of differences in averages when you have scores that you would typically talk about. The average score for this set of people is this on this, and for this set of people, it's the average score is this, rather than looking at actual percentages within each level of a variable. That's what we do with chi-square tests. And so chi-square tests are really for when you have variables with, you wouldn't ask for like an average race, you wouldn't ask for an average, whether or not they say that they have easy access to gun in the home, because this is about percentages. And so when you're talking about comparing two variables that you typically talk about in terms of percentages of people at each level of the variable, that's what a chi-square test is good for. For variables that have a lot more levels, that's when you're talking about usually comparing averages or comparing means across groups. So, so keep that in mind for your homework, because for the chi-square table, yeah, it does need to look like one that would be good for chi-square. And so if you have questions about that, you can ask me now, or you can ask about that Friday. But be doing that, and then right, don't wait till the last minute to start working on your test. Okay, so there's nothing else that I have right now, I don't think, unless somebody wants me to do another chi-square example. I'd be glad to. If you want to look at another cross tabulation example, I'd be glad to. But that's all I have for right now. So you are free to go for now, and I will send out a Zoom invite for Friday if you want to stop by on Friday. If there's questions about the exam, let's do Friday night. So, okay. You are, yeah, free to go. If you don't have any other questions, or if you do, I can talk to you more about this or something else.
I actually do have a question for you.
Yes.
It's about the exam, so I'm not sure like if you can answer it, but there was a question about a z-score indicating 80% of a sample. And when I looked in the normal distribution chart, I didn't see like anything that would show 80%. So is that a chart?
Right. What is it? It only goes up to 50%, right?
Yeah.
Okay. So remember that it's symmetrical. And so what is the complement to 80%? What's left over between 80? Yeah. Okay. That's a hint as to where you should be looking at in the table. Okay. Because it's just going to be you know, it's symmetrical, and the z-scores just start over and they start going negative when you get past the 0. So yeah.
All right, thank you.
You're welcome.
Bye.
Bye-bye.